Our lesson today is over balanced and unbalanced forces. A force is defined as a push or pull. We measure forces in units called newtons. And that is abbreviated capital N. And generally in science, we use a spring scale to measure force in newtons. So let's talk first about balanced forces. We are under forces all the time, different forces. Two that you are constantly bombarded with are gravity and friction. Those two things you just can't get away from here on Earth. But all the forces that are acting together on an object are known as the net force. And when the net force of an object is zero, then that object is under a balanced force. For example, the book sitting on the table here. The book is pushing down on the table at the same force as the table is pushing up on the book. So the book sits there. This is a balanced force. Forces can also be, an object can also be in motion and have a balanced force. For example, the Earth orbiting the Sun. This is a balanced force. The net forces are zero. When forces are unbalanced, then the net force does not equal zero. And the force then would be unbalanced. This unbalanced force causes a change in the speed or the direction of an object's movement. This change of speed or direction is called acceleration that we've talked about earlier. The force must be large enough to overcome the object's inertia. And inertia is the object either sitting still or moving in a certain direction at a given speed. Remember that acceleration occurs when an object speeds up, slows down, or changes its direction. And acceleration only occurs when there is an unbalanced net force. So let's take a look at how we determine net force. Let's take this cube, for example. If we have a net force of 50 newtons pushing from the left, and we have 50 newtons pushing from the right, then we have a net force of zero, and the object is balanced. But let's say that we have a net force of 100 newtons pushing from the left, and we have a force of 50 newtons pushing from the right. At this point, we are going to have movement to the right because the net force is greater, or the force is greater on the left than the right, and the net force here would be 50 newtons to the right. So what if we had forces that are acting on the object in the same direction? Let's say we had a force of 20 newtons and a force of 10 newtons, both moving in one direction to the right. In this case, we would add the forces together, and our net force would be 30 newtons to the right. And so if we take this same cube and we pull from each direction instead of pushing from one and pulling from the other, or pushing from both directions, what if we pull from either side? And let's say we have a force of 10 newtons pulling from the right and a force of 10 newtons pulling from the left. Well, in this case, we have pulling from both directions, from each direction at the same, so we would have a net force of 0, and we would have a balanced force. But what if we change that and we had a force of, say, 15 newtons pulling from the left and 10 newtons pulling from the right? In this case, we would have a net force of 5 newtons, and the box would move to the left, so we would have 5 newtons to the left. So let's remember that forces can be either balanced or unbalanced. We measure forces in newtons, and in science, generally we use a spring scale to measure forces. These forces will relate to our next lesson, Newton's laws, where we'll talk about Newton's 3 laws of motion: the law of inertia, the law of force and acceleration, and the law of action and reaction.